So for this, let's recall that to find any probability concerning x and y, from the joint PMF of x and y, we can sum up the joint PMF over those values of x and y. So in this way, we can find any probability concerning x and y from the joint PMF of x and y. We can sum up the joint PMF. For example, if I want to find the probability x is equal to y, I'll just sum up the joint PMF over all those values. X is equal to y, sum up the joint PMF over those values of x and y. So this is something that's very important to recall. Whenever you want to find any probability concerning x and y, given the joint PMF, you can just sum up the joint PMF over those values of x and y. If you want to find the probability x is greater than y, we'll sum up the joint PMF over all those values x is greater than y. So now let's apply this to finding the marginal PMF of x and then marginal PMF of y. So for marginal PMF of x, now the marginal PMF of x is just like the PMF of x. We just call it the marginal PMF because we are obtaining it from the joint PMF of x and y. But this is again just going to specify all the values that x can take, which in this case we know are 1 and 2, and find their associated probabilities. Because the joint PMF gives us joint probabilities, right? This is not the probability that x is 1, neither is this the probability x is 2. This is the probability x is 1 and y is 0. The joint PMF gives us the joint probabilities of both x and y. From the joint PMF, we want to find the marginal PMF of x, which will state all the values that x can take, which we know are 1 and 2 in this case, and their own probabilities. So now for marginal PMF of x, now the probability that x takes a value small x is just going to be that you sum up the joint PMF of x and y. You sum up the joint PMF of x and y over all y. Probability x is x and y is y. So again, like we said, to find any probability concerning x and y, here we want to find the probability that x is x. We'll sum up the joint PMF over all those values where x is equal to small x regardless of whatever y is. Right, so what we're saying over here is to find probability x is equal to x, sum up joint PMF over all those values where x, now to find the probability x is x, sum of the joint PMF for all those values where x is equal to x regardless of what y is. We're not putting any condition of y. Regardless of what y is. So this is the idea. If you want to find the marginal PMF of x, you essentially want to find what probability x is x for all values x, small x, the random variable x takes, right? So we'll just sum of the joint PMF over all those values where capital X is equal to small x regardless of what y is, because we're not putting any condition on y. So if we apply it to this case, so we know over here that this is x, and we want to find the probability that x is equal to x, and we know x takes two values from here. The first value that x is going to take is 1, so let's look at 1. Right, so we want to find now the probability that x is equal to 1. Right, we want to find this. This is essentially going to be, we're going to just sum up, right? We want to find, let's right, so this is x is equal to 1. We want to find the probability that x is 1. For this, we'll sum up the joint PMF over all those values where x is 1 regardless of what y. So here x is 1, y is 0. This is x is equal to 1, y is 1, right? So basically, we'll just essentially sum up all the values in the column corresponding to x is equal to 1, because in all those values, x is equal to 1 regardless of whatever y is. So the probability that x is 1 is just essentially the probability x is 1 and y is 0, or the probability that x is 1 and y is 1. So we just sum up the joint PMF over all those values where x is 1 regardless of what y is, which is just the, so this is like x is equal to 1. So sum the joint PMF for all those values where x is 1 regardless of whatever y is. right? So to find the probability x is 1, just sum of the joint PMF of all those values, right? So this would then just turn out to be 0.3 plus 0.25 as 0.5. So now see, now for the next value of x, which we can see over here, is 2, right? So the next value of x is 2. So this is 2. Right, so 2 and okay, so let's just write this first. We want to find the probability x is 2 now. Right, so if we just to find the probability x is 2, we'll just sum up the joint PMF over all those values where x is 2 regardless of what y is. So it's going to be this value and it's going to be this value, right? It's going to be summing up the column corresponding to x is equal to 2 because over here x is 2 regardless of whatever y is, right? So this x is equal to 2. So just sum up the joint PMF over all those values x is 2, which is this column corresponding to x is equal to 2 because it doesn't really matter over here what y is. So this is the probability x is 2 and y is 0. And then you also sum out the probability that x is 2 and y is 1. And this would be 0.25, sorry, 0.2 plus 0.25 is 0.45, right? So in this way, we found the marginal PMF of x, right? We found, so for the marginal PMF of x, we found, x takes two values of 1 and 2. We find the probability that x is 1 is 0.55 and the probability x is 2 is 0.45. So if you just write it nicely, write it like this. So x takes value 1 and 2. Probability that x is equal to 0.55 and 0.45. So this is the marginal PMF of x, right? So this is the marginal PMF of x, where we know what values x takes and the associated probabilities. And we can also check this PMF by seeing that it does sum to 1, right? Because 0.55 plus 0.45 is 1, because we know the sum of all probabilities in the PMF have to be 1 and it does hold here. Right, so now let's find the marginal PMF of y. And it's going to be very similar to x for marginal, but the focus is now going to be on y. So we want to find the probability. So we know y takes two values 0 and 1. We want to find the probability of each value. So probability y takes a value, small y, is just you sum up the joint PMF over all those values where x is x and, where y is y regardless of whatever the x is, right? Remember we said to find any probability concerning x and y, so sum up the joint PMF over those values of x and y. Here we're interested in finding the probability y is equal to small y. So we'll sum up the joint PMF over all those values where y is equal to small y regardless of whatever x. So for all possible values that capital X is equal to small x, right? So to find probability y is y, sum up the joint PMF, this is what this says in words, sum up the joint PMF over all those values where y is y regardless of what x is, right? We're summing up over all possible values, capital X is small x, regardless of what x is, right? So if you want to find the probability y is y, just sum of the joint PMF for all those possible values where y is y regardless of what x is. So let's apply it to this example. Here, okay, y, the first value the y is going to take is 0. So this is 0. We want to find the probability that y is equal to this value. They want to find the probability that y is 0. Right? So if we just look at this, so this is 0, right? So this is 0 and this is 0. So like we said, we're going to sum up the joint PMF over all those values where y is 0 and so where y is 0 regardless of what x is. So y is 0 for this row corresponding to 0, right? Like if we just look at this represents y is 0. So this row corresponding to y is equal to 0 includes all those values when a joint PMF of y is 0 regardless of what x is. So it's this value and it's this value, right? Because over here we have y is 0 regardless of whatever x is, right? So we're just summing up the row corresponding to y is equal to this. So probability y is equal to 0 is essentially the probability y is 0 and x is 1 plus the probability y is 0 and x is 2, right? So summing up the joint PMF for all those values, so y is 0 regardless of what x is. X could be 1 or x could be 2, right? So this is just 0.3 plus 0.2 is 0.5. Now we want to find the next value y over here that we notice is essentially 1, right? So then here we have value 1. Now I want to find the probability that y is equal to 1, right? So we want to find the probability that y is 1. For this, we're going to sum up the joint PMF over all those values where y is equal to 1. So this is y is equal to 0. This is y is equal to 1, right? The row corresponding to y is equal to 1. So, um, so basically, okay, sorry. So this is, we want to find the probability that y is equal to 1. We're going to sum up the joint PMF over all those values where y is 1. And we know in the second row, y is equal to 1. And we're going to do this regardless of whatever x is, right? So in these values of the joint PMF, we know y is 1, right? So we're looking at this row corresponding to y is equal to 1. So essentially, this is going to be the probability y is 1 and x is 1, or the probability y is 1 and x is 2, because you have to sum up the joint PMF for all those values where y is 1 regardless of what x is. We're not imposing any condition on x. 0.25 plus 0.25 is 0.5. In this way, we can also find the marginal PMF of y. We found both values of y is 0 and 1 and the associated probabilities. So if we write it over here, so y we know takes value 0, 1, and the probability that y is 0.5, 0.5. So this is the marginal PMF of y, which is telling us the values y takes, which you can see from here are 0 and 1, and we found the associated probabilities 0.5 and 0.5, right? And we can also see that this PMF also sums to 1. So it does meet the condition of a valid PMF.